Hello, we are the group 2 and we are going to present you the pesticide effects in the soils. Our group is conformed by Andrew Lara Sandoval, Nicolás Otalora Ramirez, and Cristian Santiago Tobar Bejarano. Introduction. Man has practiced some form of pest control since the beginning of the agricultural times. The principles of seed treatment, fumigation, and the use of synthetic preparations to kill unwanted pests were known to the ancient agriculturalists. Pesticides have controlled weeds, vectors of human and animal diseases, and have protected structures from damage. As the world's population increases, so does the need for food production. However, pesticide residues may constitute a significant source of contamination for air, the water, the soil, and the food. That's why, in many countries, seeking to mitigate this risk, protection measures and limits have been placed on the amount of pesticides and can be applied to the crops. The amounts of permissible residues that could be in the plants and fruits destined for their consumption. Features and classification of pesticides. A pesticide is a substance or mixture of substances intended to control, destroy, or repel some insect, nematode, fungus, animal, grass, or some other form of organism, whether terrestrial or aquatic, that in some way with its presence significantly affects a culture. There are several types of pesticides such herbicides intended to control herbs, and they have a great variety. Insecticides intended to control insects, fungicides intended to control fungi, and fumigants that add substances that in a normal temperature and pressure are in the gaseous state and serve to control multiple types of pests. Herbicides. The herbicides contain compounds of multiple physical chemical substances. Some can be applied directly to the soil and others can be applied directly to the silver. There are several application techniques. The best known is incorporation into the soil, which minimizes volatilization. Other techniques are surface application, sequential application, and pre-plant application. The insecticides are chemical compounds specifically intended for the elimination, repulsion, and treatment of insects and pests. This is achieved through the inhibition of vital enzymes. These substances are classified into several by the mode of action, such as broad-spectrum insecticides, since they are effective to eliminate multiple types of species. There are also specific insecticides that are characterized by being effective against specific species or related species each. Fungicides. They are chemical substances designed to treat diseases in plants, animals, or humans caused by fungi. For the context of these expositions, we will specifically talk about agricultural fungicides that are used in crops to protect them from damage caused by spores. They optimize development of silver because they stop leaf diseases, which guarantees quality photosynthesis for better productions. The fumigants. They have a fundamental characteristic for their operation, which defines them, and that is that they have an exceptional capacity for the diffusion and in addition of being effective against multiple types of pests. They can easily penetrate in many types of material, tissue, and even the human skin. Agricultural fumigants penetrate the soil and dissolve it in the water present there, allowing they to move effectively across the entire surface to be treated. Pesticides effects in soil. There are several properties closely related to the impact that a pesticide can have on a given soil, and whose different configurations determine whether the effect can be dissipated or not. These are Organic matter content, type and proportion of minerals in the soil, cation exchange capacity, pH, and porous space and pore size distribution. Pesticide rotation in soils. The rotation is a physical process without change in the chemical nature of the molecule, in which an accumulation of the pesticides occurs on the surface or inside the soil particles. The processes of absorption and adsorption of the pesticides with the soil molecules together can be called absorption. The transfer of a substance from its liquid phase to its solid phase in the solid is called radiation isotherm. For the case of the pesticides, studying the reception, the radiation isotherms corresponding to each chemical substance allows determining what the pesticide's affinity will be to remain on the soil. Pesticide transport in soil. Soil is a porous material whose structure is determined to the greater or lesser extent by the shape and the size of each individual particle, which is why the solutors can be applied to the soil move in the process called convective transport, in which the solute particles are transported along with the water, and the capacity of the water to serve as transport of the pesticides in the soil depends on the porosity and the continuity of its pores. Pesticide degradation process in the soil. The degradation of the pesticide in the soil is understood to be the process by which the chemical substance or substance that make up the pesticides are transformed into simpler molecules. Although this does not mean that they are less toxic. This process can be carried out at home, abiotic circumstances, hydrolysis, photodegradation, or redox reactions, ambiotic circumstances. The organisms that are present in the soil carry out a biodegradation process that is very important because they use the components and substance present as the form of energy and nutrients by degrading the elements, in this case the pesticides. The rate of biodegradation of the elements that make up the pesticides is given by different factors. The pesticides bioavailability, the substances that make up the pesticides are more available to microorganisms, and they are dissolved in the water present in the pore space. Composition and activity of microbial communities in the soil. The composition of certain pesticides favors the growth of the population of the biota that benefits from its application, or therefore they degrade it faster. Environmental conditions. The chemical composition of the soils, the pH, or the texture significantly influence the degradation of the substance present in the soil, in addition to climatic factors.
Well, good afternoon. Well, continue talking about the impact of the plaguicides in the environment, most specific in the ground. We have to take care or be focused in two principal parts. The first part are the chemical part. The chemical part is about the changes of the levels of different elements that cause the losses of a lot of properties that a ground can have. Well, we have to take care because all over the world, a lot of grounds and complete environments, ecosystems were destroyed by the indiscriminate use of these agronomical products. Well, the effect of the plaguicide depending a lot of factors. First of all, the kind of ground that we're going to treat. Because yeah, it depends on the properties and the necessities of each ground that affect the ground and the impact of the plaguicide. And in the other hand, we have the method of application, because that affects too. In method application, we have two methods. First are aerial application and terrestrial application, and this impact in how the leaf organisms are affected by this. Well, talking about the consideration in application, we have, as I said, aerial application like airplanes that reduce the precisions. Why this reduce the precisions? Because when we use airplanes, we loses a lot of control in too much factors. First, factors that affect is speed. The speed of the plane affects in how the plaguicide is going to land, the height of the plane, and even the wind, because we are using two small particles. When we use two small particles, the wind can change so radical the directions. In the other hand, the terrestrial application bring us more precisions because there are little more factors, are less factors than in the aerial applications. We in terrestrial application we can control like the levels and the reach of the plaguicide because we have in our hands the range that can the plaguicide reach. Well, we have these factors: adsorption and desorption, colloidal fraction, activity, degradation, and persistence that are the most affect in the ground. Adsorption and desertion. That means that the ground has a natural system, we can say, that absorbs and desert the plaguicides and all the external factors that affect the ground. Well, it depends of the ground, the level of absorption and desertion, but we have to take care of the element that contain the each plaguicide because that can affect the absorption and desertion. There's a lot of ground that can desert the same that another. Yeah, so if you use um, bad plaguicides that are not made for each specific ground, we can completely destroy that ground. The colloidal fraction means that that colloidal fraction that have the ground. This colloidal fraction is composed by organic and inorganic part. The inorganic part is the part that can be composed by the elements, the rocks, and that stuff. The organic, it depends in the live organisms that live in the ground, and well, and the well that eh, well, talking about degradation, it depends in the plaguicide the time that stay in the ground, because some plaguicide stand in the ground like for almost 20 years. 20 years, that's too much time for the for a plaguicide in the ground that can affect and intoxicate our ground. That is relatable with the persistence that have that element to stay between the time in the ground. And in activity, we have the activity own that the own that the what well that the own ground has, like the changes of temperature and intercam of properties and nutrients. And that's it. Thank you so much.